Remember, like I said, a correct answer will not include a negative exponent, okay? So what we have here in parentheses is 3a squared b times c to the negative 5, close your parentheses, raise it to the negative 3 power. Okay, if you look at your rules and you look at your negative exponent rules, I see here that if I have something raised to the negative power, I know this is just one single b, but I'm just saying it's something. This is something raised to a negative power. And what you do when you have something raised to a negative power is you bring all of that something to the denominator and you put it under 1. So let that be our first step. What we're going to do is bring all of this down. Our negative 5 is not affected because doing this rule was to affect this negative 3. It now becomes a positive 3. And then once we get here, we notice that we have a power rule, a product rule. It would actually be a power rule. This is going to be a power, and everything's going to get this power. I might have written that down. Okay, follow me here. I just want to make sure that the rules that I wrote down are like completely correct. But let's look right here. We notice that we have a set of parentheses with terms inside of it all being raised to a power. So this means that everything inside of here gets this power. Individually, everything gets raised to the third power. So let's do 1 over, even your coefficient is going to be in parentheses 3 cubed. And then if you scoot over to your next term, I have an a squared. So we have in parentheses a squared, raise it again to the third power. And then right here I have a b raised to the third power. And then lastly, I have a c to the negative 5 power. And I'm going to raise that to the third power. Okay, so let's actually evaluate each of these. What I get is 1 over 3 cubed would be 3 times 3 times 3, which is 27. A squared cubed. Squared cubed is a power to a power. And our power rule right here says if you have something raised to a power and then raised to another power, you multiply your powers. So I have something raised to a power, raised to another power. I'm going to multiply these powers. 3 times 2 would be 6. So I get a to the 6th power. And this is technically like a power rule because there's that invisible 1. So it's like power to a power, multiply your powers. 3 times 1 is 3. And then right here, I have c raised to the negative 5th power, raised to the 3rd power. Power to a power, multiply your powers, c to the negative 15. Some people would think right here that they're done. I moved stuff down to the bottom, which got rid of this initial negative exponent, and then I evaluated all of the rest of the problem. But this c being raised to a negative 15 means that this is not a correct answer because it can't include negative exponents. And so if you remember right here in our negative exponent rules, if you have something in the denominator being raised to a negative power, what you do is you bring it up to the numerator. So it goes from being in the denominator to being up top. So only this right here needs to move up. Okay? So we would actually have 1, this moves up, right? So 1 times c, it is now a positive 15 over 27 a to the 6th b cubed. That would be your final answer. Okay, so far this is about half of our review homework. Remember, if you see something that says to use the product rule, you'll multiply your coefficients first together and then your variables using the actual rule where you keep and add. Let me see. Actually, let's do an example like that. Okay. So for example, if we have in parentheses negative ax to the fourth p to the sixth, weird to have x and p, but that's what we got. Open parentheses, 3y to the fourth, x to the fourth. Okay, so what we do here, there's a couple of different things that you can do. We could write it down and it be kind of complicated, but I don't really think there's any reason to do that. We're just going to multiply the common things together. So I have a negative 8 and I have a negative 3. Those are just coefficients. 8 times 3 is 24. Signs are different, so it's negative. And then if you notice, I have an x to the fourth and an x to the fourth. Well, the product rule says that if you have the same variables and they're multiplying, what you do is you keep and you add. So I'm going to keep my x and I'm going to add and get 8. So x to the 8th. And then if I look, I've got a p and no other p. So I'm just going to write p to the 6th. And then I have a y to the 4th with no other y. Sorry, they're the same color. I only have 4 colors. I could have used black, I guess. These are not the same. So they literally can just get written. You can do it pxy. It really doesn't matter. Multiplication is commutative. It can move around. So no matter what order your variables are in, as long as your exponents are okay, then your problem is correct. So that would be your final answer. And that's multiplying the coefficients together and then using the product rule where you can. Bye, y'all.